panel.
Yes, it's the Cracking Calculus by Design panel. I think there was something about reimagining calculus, oh, and closing equity gaps through reimagining calculus. So, but I'm gonna talk first and I'll introduce myself in a second. But first I want to give you guys like 30 seconds. You came here, like there's lots of things happening about calculus and like getting rid of prereqs at the community college. So I'm just curious maybe what headspace we're in. If you guys could all take 30 seconds and just think like, what are you maybe most excited to learn about today? And what are you most nervous to hear about or, in the future of calculus? So take like 30 seconds.
What's that?
You can
Oh, yeah.
turn to a partner, share, see if it's same, different. What are you most excited to learn about? What are you most nervous to learn about?
Around and around.
You can take, I'm counting Mississippi's, give you a few seconds to, gather your thoughts.
What drew my attention was the focusing on active learning and conceptual understanding.
All right, other thoughts? Things we're nervous about as we reimagine calculus? Yeah.
We're getting rid of.
Making sure, what we're getting rid of and making sure our students, when they transfer, are going to be able to compete with the students who were out the transfer institution.
Can I get a raise of hands of who in here is from a community college? And anyone from a Cal State? Okay, and anyone from a UC? All right, so I want the Cal States and the UCs to listen, to take that comment and put it close to your heart and keep it in mind as we carry on. All right, so I am Michael Banworth-Kuhn. I go by MBK, and I am currently at Cal State East Bay. It's my third year in the math department. And I'm part of this team from the Include grant, which stands for Inclusive Novel Curriculum to Leverage Representation of Underserved Communities in Data Science. So we are building a data science major on our campus. And the big goal of our major is really to do something different that invites students into this field who really would not typically think of themselves as a data scientist or really just like STEM inclined in general. Okay. So that's sort of where I'm entering this project from. And so the reason I am here today is that I guess hopefully not that hot of a take, but who knows? In order to do this, to create this kind of program, I truly believe that it's imperative that we reimagine the STEM pathway to better serve all of our students. And what I'm going to talk to you about today is what that really means to me is actually just bringing these math classes into the 21st century. So I'm going to share with you a little bit how I am designing a class for our data science major that sort of is like a way of doing this. And the big, maybe most controversial part about this is that the class I'm going to talk about today is a calculus class with no prerequisites. And I like to say, I'm actually not the first person to think of this. There is a class like this that exists on this campus at UCLA in the Life Sciences Department. So a little bit about me, just so you can kind of understand where I come from, where I'm approaching this from. I grew up in Albuquerque, New Mexico. I was the middle of 3 kids, so I like to think that, I was I had to become a problem solver very early on, being the middle kid. But these are my parents. They were born in 1953, so they were definitely hippies. And they just had like a really strong sense of like both do well in school. They valued science education. So that's sort of like what my mission in life is maybe just like doing good things for the community and also like doing really well in school. And I think, that's what sort of led me to pursue this path of mathematics. It's something that my family valued. And I did my PhD at UC Riverside. I graduated in 2019. And I am what's called a mathematical biologist. So I use math to study problems in biology. And really, this is like work that's at the intersection of math, data science, computer science, right? And then applying, for me, that's really about applying these tools to problems in biology and medicine. So, for me, that's fine. All right. For me, what math looked like was once I started sort of doing research and thinking about mathematical biology, was like I was given some sort of like biology problem, and it's like, okay, here's this like issue that like biologists are thinking about it. There we go. All right. So here's some problem, right? And then basically my advisor's like, oh yeah, go figure out what math you would use to like model this, code it up, fit it to data, and then like bring it over to the biologist, right? Which is really different than how I was taught math as an undergrad, right? So with this kind of thinking, properties of mathematical objects are tools to explain science, right? But the training that you get, wow, where's all of my slides? I'm not sure what's going on with this. Anyway, I might just have to talk you guys through this because I really messed it up because I'm not a PC person.
Yeah, nobody here is, so we're in trouble.
Weird. It's right.
Okay, Michael, you got.
I think this is PC revenge.
I could do. All right. So I think, yes, when you enter this world of like more applied math, properties of mathematical objects are tools to explain like applications, right? But when we teach math, it's the other way around of like, we should just study properties of mathematical objects. And not, like figure out as much as we can about them. So now, that was during my PhD, I learned properties of mathematical objects, can help explain science. And now I'm sitting at Cal State East Bay as a professor in the math department. And I'm asking myself this question of, okay, like, I have all of this experience. What are the most important skills I can teach my students? Right? So for me, that's how to use math to explain problems in their field. And then I got the opportunity to be part of planning the new data science major. So this became more of a broader question of, well, what topics should an undergraduate data scientist know? But I want to expand that question really to what math topics should an undergraduate STEM major know? Okay, so when we normally think about who our math classes are for, I think some of the majors that come to mind are maybe engineers, physicists, computer science, and then, the very tiny pool of math majors. But, when we look at what some of the fastest growing jobs in the STEM field are, it's more about, yes, data science, biomedical engineer, computational biology, bioinformatics, biochemistry, biophysics. We have our pre-med, those kind of people, right? So sort of asking those fields and this has a slight biology bias because that's where I entered this work from. When we ask those experts what math they want students to know, they say dynamical systems, feedback. So one application of that is how feedback leads to oscillations in glucose levels. So that's nonlinear ODEs. National Academy of the Sciences says emphasis should not be on the method. So I think they're meaning like symbolic manipulation, but rather on how these methods elucidate to biology, ordinary differential equations. But, it does take a while to get to a traditional ODEs class. So maybe made tractable via Euler's method. NSF, an American Association for Advancement of Science, say nonlinear dynamics and spread of disease. Okay. So I just wanted to walk you through really quick, like what it would take a student at East Bay to get to classes that actually teach them this stuff. Okay. So most of our students start at college algebra. They go to pre-calculus. They go in Calc 1. Biology majors, that's it. That's all they see, right? They're not getting there. If you keep going, you do Calc 2, Calc 3. That's where we lose all the chemistry, biochemistry majors. CS majors are done with calc, but they need linear algebra. Then, you know, some physics majors will take intro to ODEs. There's something with linear algebra, right? So in intro to ODEs, you don't even normally get to these nonlinear dynamics. At least at Cal State, you
Why,
say, right?
why, I mean, at community colleges, we can go Cal 2 straight into ODs.
Yeah, I guess it sort of depends on the major, but not everyone takes Calc 3, I agree. But even then, to get to nonlinear dynamics, you have to go from Calc 2 into ODs, and then you still, most of the time, unless I'm teaching it, you're not seeing any nonlinear dynamics, right? So this is a very long road to get to what the students need. All right, so I just want to ask the question, the way this is set up, who is calculus for, right? And so I don't think the STEM pathway is really set up to serve the majority of students that are taking calculus, like what they are going to need in the future. They don't see applications because you can't do both. You cannot do all of these like symbolic manipulation problems and still have time to get into the media applications. You just can't do it. The applications always get left out. And there's absolutely no data and no computing here, which is really what they need the most experience with in their future fields. The emphasis is really on symbolic manipulation. Okay, so my solution to make calculus for everyone, to serve everyone, is to yank it into the 21st century. My pitch for this is like, Newton had a pencil and paper. It's 2024. We have computers and tons of data. So like the big things we need to think about are, it's extremely useful to describe how systems change using differential equations. And another thing that just makes these analytical methods of Newton's time like totally like not the best entry into mathematics is that like when we're dealing with a lot of these models, when we're modeling things using differential equations, then these differential equations, the solution curves almost always exist, but we can't write it down explicitly. We can very rarely find an explicit solution, right? So it's just like this symbolic manipulation is just sort of like not the best entry point into these ideas for that very reason. So, so to me, this symbolic manipulation is 19th century calculus, and that's really the reason we have to worry about these all pre-calculus and algebra prerequisites, is so that students can get through this symbolic manipulation, which is like completely not even the thing that they need to gain from going to calc sequence. All right, so a 21st century calculus class would emphasize functions, right? So we would cover functions. We would talk about relationships between input and output. We'd talk about linear functions. We talk about exponential growth. We talk about logs, probably some like sines and cosines to get through this oscillatory behavior. We could talk about limits, right? So we would talk about limits as end behavior of functions. What's happening as time is going to infinity. You have an exponential growth or decay, right? Like in one case, your limit is as t goes to infinity is infinity. The other one, you're reaching some sort of like equilibrium. And then really we actually motivate calculus and derivatives through talking about change equations, which are secretly just differential equations, right? So we really talk about how do you write down what are differential equations? It's like that typical like bathtub example where the water's coming in and it's leaving, right? And those are different types of rates. One's like a constant rate, one's proportional. So you can refer back to these like functions that you talked about, like a linear relationship, this kind of stuff. And then once you have a change equation, right, you can talk about like, oh, if I have this amount of something and I plug it into my change equation, that tells me like how my system is changing at that point. And that's what a vector field is, right? You got your two, usually like if you have two equations, you've got like your two state variables on each axis, each point. Okay, each point is like, I'm like pretty close to done anyway. I'm like, each point is a state point. You can calculate the change at that point. That's instantaneous rate of change. And then from there, you can follow vectors and sketch out trajectories. And the vector field, I call it the state space. And that is a solution. So trajectories in state space, you've just solved your ODE. You can go from that to a time series, right? So you're introducing this idea of a time series. And that's really qualitative dynamics. And then if you want to get a little bit more like accurate, then like from those back, from tracing out trajectories in state space, that's just like Euler's method. So then you take them through Euler's method, right? And that's how they solve these ODE. And then from there, like you can do a ton of different examples with fitting to data. You know, you have it like optimization, machine learning. They got everything they need at that point. Oh yeah, I forgot. So my Calc 2 class would be like 1 week of class. We would add up the area under a triangle. We would do some like, you know, example with, you know, probably like, what are those income inequality curves? I forget, starts with a G.
Genie.
Yeah, the Gini
Yeah.
coefficient or something
Yeah.
like this. That's your integration.
Ah.
Yes. So this is my secret plan for, it's not to replace a traditional calc sequence. It's just a different pathway that better serves like this whole set of students that I don't think we're serving right now. And so I think at East Bay, the model is you do a calculus type class, you do the linear algebra, and then you're really ready for most upper division quantitative science courses. Maybe not the engineering, maybe not the physics, maybe not the math major, although at East Bay, maybe. Yeah, so that's sort of the plan of the class. I just wanted to make a quick plug. I don't have like, I haven't taught this class yet, it's still in development, but UCLA has been doing this for a while. You know, something, it's similar. Theirs is really through the lens of mathematical biology. So if you want to, you know, something a little more concrete until our notes are ready, they've got, they have this class at LS30, they have a paper on it. It has really great data about the outcomes for students. I've heard lots of like, anecdotal data of how students who go through that LS30 sequence do a lot better in their next, you know, math and science classes. Yeah, so I think that there will be time for questions after we both present. So yes.
Do we do questions and then, or? Okay.
Yeah,
Okay.
at least that's what the plan has throughout. The learning lab method is everybody presents.
Can I close without saving?
Yeah, I don't.
Your slides show up on the, like on the app, we can see the slides.
Okay.
There was something slightly different than what you got, but not like.
Yeah, I
amazingly
did
different.
want to
Maybe
change
there's a
them,
more.
but I couldn't edit it.
Sit here and periodically touch it so it doesn't disappear. Just caress it once in a while. Okay, so we are a different project from Michael's, and our project is called Why, What, How Calculus. Okay, so this is a collaboration between UC Merced, which is located in the beautiful Merced Central Valley, and Fresno State, which is also located in the beautiful Central Valley, but in Fresno, naturally. All right, so if you want to abbreviate our project, it's WWH calculus. And this is not to be confused with the WWE map. Very, very different stuff altogether. Now, I just came across this video. He's explaining how you get 114% in the third probability of something. Makes sense, but doesn't make sense to us. So, in the light of our, you have to live what you preach, right? So we have WWH calculus, why, what, and how. And I'm gonna construct my presentation exactly in this way. Why? First, I'm gonna describe to you why we're doing it in the first place. Secondly, I'm gonna tell you what we're doing, and then I'll describe how we're doing it. Okay? But we also forget about who, and this is our team. So these are all the PIs between Fresno, and we have a nice combination of engineering faculty, applied math faculty, and cognitive scientists. Zenaida, who unfortunately couldn't be here, she was supposed to present, but luckily her graduate student Maribel, who's doing a lot of work anyway, came, and she's going to talk a little bit about assessment at the end. So this is the who, and initially we also had Sarah Frey, who unfortunately abandoned UC Merced. We still miss her, but she's in a different university. All right. So what exactly motivates us? Well, my son is in 6th grade now, but he was about to enter the 4th grade at the moment where we were doing all this stuff. And if you are in 4th grade, then you're given a problem like this, 23 times 1/5. And yes, absolutely, once I immigrated to the United States, I realized that fractions are this objects that were deposited by aliens on Earth, which nobody understands and just knows it's a number, a bar, and another number. But, you know, worse or better, somehow they figure it out. And they can actually come up with a solution, right, to this problem. However, right after that, I give all this 4th graders this problem. You have 23 candy, and you want to distribute them among 5 friends. How many candy will each get? And they go into a state of panic because that problem to them is very different than the first problem. In fact, this is incomprehensible combination of words that you should never read altogether, and much less do in the math class. Now, if this is, I could do the same examples from kindergarten, from the 1st grade, from 2nd grade, etc., going all the way to calculus. Because in calculus, once again, I can give this problem, and you know, the best students, the middle students, you know, maybe the worst students have, but the worst students can use AI and they figure it out. But when I give them this problem, and I wanted to make it relevant, and should have been a beer bottle. I mean, we're talking about college students, probably not a wine glass, but you know, it's in the ballpark. I couldn't find a good picture, so I put a good picture of the glass. If you give them this problem, then they look at me in a shocked state and they say, what the hell do you want us to do? And they don't see the connection between this problem and that problem. However, if we think about why math was invented in the first place, and the whole purpose of mathematics is, the last time I checked, was to solve problems. So the question of why, first reason, is how did we go from having mathematics make sense to people and be able to compute, you know, how much, I don't know, harvest they collect and how many pieces of cows, no, pieces of cows is a bad. How many cows need to be sold to a neighbor and so on and so forth. And not asking questions like, what is the number of steps I need to do to divide the number of 23 cows in 5 groups, right? And there's a reason why I actually put divided by 5, right? Because if I put, you know, 20 divided by 5, then somehow maybe they can figure it out. But if you divide 23 by 5, forget it. I mean, that's the end of the earth. Nobody can do it but the aliens who deposited math 5 million years ago, right? And so this is one of the reasons that somehow everything went upside down and inside out, and we need to put it back on its footing, because this is actually what all of our subsequent STEM classes are asking for. They don't need them to do that. They can stick it into Wolfram math and figure it out, but they need them to do this. And this is a one-step problem, right? I mean, typically you have multiple steps, mathematical steps that you need to take. So this is the motivation, one motivation why. And the second motivation why is, of course, this. We've talked about equity gaps for many, many sessions here and many, many talks, and it's real. It's very real for us at CSU Fresno and UC Merced, because majority of our student populations are coming from underrepresented minority populations and from first generation college. So this is our primary audience. And yet what we see is, so these are some graduation rates based on the grade, and you see this equity gaps, right? First generation college, URN students, they are performing worse across the spectrum of the grades. Maybe with the poorest grade, there's some combination. Everybody fails equally, right? But when they're performing well, they're performing poorly. So this is what we want to do. 2 motivations: make it sensible, and also try to close the equity gaps. All right. So what exactly we decided to do in order to accomplish something like this? So we embarked, and I apologize for the cough, it's going to continue, but I'm not contagious. This is like asthma 5 weeks after I had a cold, so, you know. So basically we are reforming how we're teaching calculus and what we're teaching in this calculus. And our reform has 3 components. One of them is we're reforming the curriculum. And that's one of the most crucial components, I would say. How we're reforming it, we're turning it on its footing, and we're focusing on conceptual understanding. We're focusing on problem solving and problem solving with the applications in mind. And we're also focusing on culturally responsive approach to teaching. So that's one big component. Next one is training and support for instructors. This has been another very crucial component of that. We need to create avenues for the instructors, first of all, to get the materials, to become comfortable with materials, to have a mentor there that they can go to and ask about those materials, and also provide some training on things like culturally responsive approach. So that's another very, very important piece of our reform. And finally, we need to create, and sometimes not even create, but we need to expose our students and motivate them to use the support systems that a lot of times already exist on campus. Almost all of our campuses have tutoring centers. When do students appear in the tutoring center? Anybody?
The day before the test.
That's correct. That is the correct answer. They go there the week of the exam, right? So in our classes, we need to provide motivation so that that doesn't happen the week of the exam, because guess what? The week of the exam, you know, is a bit like, I'll never forget it when I was teaching in Berkeley. I was numerical analysis class, and I was a postdoc at that time, visiting assistant professor. So I was in my office at 11:30 p.m. the day before the exam at 8 o'clock in the morning. And the student was sitting there and he was begging me to one question, Professor Tokman, one question. I said, well, okay, fine. It's 11:30, but one question. He came in and he said, you know, I don't understand chapters 5, 6, 7, and 9. Needless to say, we only studied chapters 5, 6, 7, and 9. So, 8, he didn't have a problem with it. Okay, so exactly all of those components, I think, have been very crucial to what we've been able to accomplish. Now, how exactly we accomplished this? Okay, now how? How did we reform the calculus curriculum? Active learning, active learning, active learning. If the student is sitting in your class, especially after the pandemic, and they literally, after the pandemic, when I started teaching, I was a department chair during the pandemic, which, you know, I didn't cause it. It just happened that way. And I taught before the pandemic and after the pandemic. And we all know that when students returned to class, they thought that they're black squares with a name written across. And you literally could do this in front of them and nothing would happen. There was no, you know, realization that there's a faculty. And my classes are always very interactive. And, you know, we really need to get them engaged. They need to be working on things. Now at UC Merced, we have classes of the size of 270 students. How are you going to make a class of 270 students work, right? Learning assistants. Learning assistants have been absolutely essential component of what we're doing. We have undergraduates who already passed calculus, who are getting training in how to teach, who are walking around, and we have an instructor who, instead of standing at the board and reciting everything that the students are not paying attention to, gives mini lectures and then assigns the worksheets on this mini lecture, and then himself or herself, together with the learning assistants, dividing them in groups and going around and seeing how the students are engaging with this material. Okay. How do we do training and support for instructors? At first, we did bi-weekly meetings where we would invite experts to talk about things like culturally responsive learning, and also provided environment for them to have a discussion. So for example, if somebody was experimenting with a standard-based grading, this was an opportunity for them to share what exactly they're doing, how they're doing it, how it's working out or not working out, and hopefully people who would adapt it later would not repeat some of the mistakes, right, and would try it or not try it. So we had to provide a venue where, and I think what was very important also is that this venue was across 2 campuses. It was UC Merced lecturers and faculty, and it was also Fresno State lecturers and faculty, because typically those 2 institutions don't talk to each other at this level. Online resources, a lot of those lectures by experts, we recorded, we posted them on the box so that the person doesn't need to come to the same lecture, so that they can actually watch it later, or new people who are joining in have access to those resources. And also, we've provided a whole spectrum of curriculum materials that were developed by our team to all of the our participants. Okay. Support systems. Support systems, it was much easier when Sarah Frey was with us and she was the Dean of Undergraduate Education. It's always good to have a Dean of Undergraduate Education on your team because she is the one who is controlling all the tutoring services. So it was very effective when she would, we would discover that they're having problems with block. So we could contact directly the tutoring center and say, could you do some workshops or some additional things on block? And then in class, our instructors would give extra credit if the students actually went and participated in this workshop. And because, information travels, right, you could actually check that and give them this extra credit. So that worked really well. It's much harder when you don't have the Dean of Undergraduate Education, but we had an interim dean, now we have a permanent dean, so we're hoping we're going to reinstate all those connections again. All right. Now let's do step-by-step curriculum. One very frustrating thing for me is asking students what have they learned in calculus. And I've done this experiment numerous times. And if you ask them, what have you learned in calculus? Even those who've gotten an A+++, what do they say usually?
The power.
Differentiation and integration. That's what you hear, right? Now, if you're going into the school that teaches you to fix cars, and you came out and people ask you, so what have you learned there? It would be very concerning for me if they said, I learned how to unscrew the screws and tighten the bolts, right? I would prefer if they said, I learned how to fix cars. Now, what are the cars of calculus? It's functions. What calculus is about is study of functions. And why do we need functions? Is because everything around us we can describe as a function. So we split our whole calculus curriculum from that perspective. This is a study, this is your animal, this is your car that you're studying. You're studying functions, and why you're studying functions is because in biology, we need a relationship between, I don't know, level of blood sugar and, your health, some measure, right? In physics, we need to know where this planet is in a particular location at a particular time, et cetera, et cetera, et cetera. So our first module is talking about functions only, talking about why they're needed, how they're represented, how they're helping us figure things out. And then we enter the discussion is what can functions do? Well, functions can increase, functions can decrease. If this is a stock portfolio you're watching, it's better if the latter doesn't happen. So you want to know, you want to be able to predict, you want to be able to analyze. And only then we get into, well, what are the tools that are allowing us to figure out it easier, right? Because if you have a table of values, it's very hard to figure out if things are going up or going down. And then we start bringing the tools. Then we're bringing integration, then we're bringing differentiation, and then we're looking at those concepts from that perspective. These are the tools that help us understand what the function is doing. Okay, and once again, we're trying to do all of it in the context of applications. So in other words, in this problem 1, problem 2, we're more likely to give you problem 2 and explain in that context of what a function does. Because then you have a picture, then you have a natural understanding. And I really wish that K through 12 did the same thing, because little kids don't understand this time. They do understand if you have 2 candy and I have 3 candy, then we both have 5 candy. And then you can explain the addition. So the same thing we're using in our calculus classes. So these are kind of roughly the modules. They're all labeled and the curriculum is labeled based. So these labels, they have a meaning. There's a meaning to this madness. Every letter represents something. So this is our curriculum development group, and the teaching materials that they develop are a combination of things. It's mini lecture notes, or if you have a fully inverted classroom, there would be references to the videos that the students and the worksheets that students watch prior to the lecture. So we tried 2 versions. We tried partially inverted and fully inverted classroom. Different instructors are teaching it. So we are getting about the same results from both. I can't say that one of them is more effective than another. It seems like it's pretty much consistent. Pre-lecture notes, discussion worksheets, in-class worksheets, and projects. And I have a video, but it was hard to play the sound here and everything. But the videos of our new faculty who just joined. She's never taught calculus 2. We dumped all the stuff on her, and she is delighted, which is a
Oh,
really
that's
good
great.
outcome. Yes. And I have a video with her telling that she's delighted. It was only one take. I was
Okay.
impressed. Okay, so in which format our materials come in? They come in 2 repositories. One repository is sorted by developers, another repository is sorted by topics. So we are not restricting it. This is how you're going to do it. We also have a Canvas template of selected material. So if you don't want to figure out, if you don't want to have options, you can just go to this Canvas template. But most people do want to have some flexibility, especially as we're in the age of AI and, problems do end up unchecked before you even post them. So you can pick and choose some of the problems, some of the materials from sort of a set of things that we're offering. And a portion of our teaching materials is also OER, and it's part of the Learning Lab LLID that they're releasing, so all of it is going to be there. But internally, so we have, for example, this linked sheets where you can go and, you can see the topic and you can click and go to the lecture that is developed by Keith Thompson, or go to his worksheet, and the same thing exists for other developers as well. So it's very easy, and everything is on Box, so it takes you directly to Box. Okay, some stats about our project. We basically have at UC Merced, this is how we teach calculus now. As a department, we decided that this is what we want to do. It's not one section, it's not 2 sections. All of our classes are like that. And this is because we're awesome.
That is true. Maya.
As a former
As a
chair
for- another
and
former
as
chair.
the next former chair, so we think we're fantastic.
Yeah.
These are the number of students we're talking about who have had it over the last 3 years. So it's about 2,500, close to 2,500 in UC Merced. In Fresno State, it's close to 2,000. And for Calculus 1 and Calculus 2 are also high numbers. These are the number of instructors who participated. Now, these are, of course, instructors. Most of them are teaching multiple classes. And so, I'm double counting some of them between Calculus 1 and Calculus 2. Okay, so the numbers are large. So since we have these large numbers, an integral piece of our project was assessment. We wanted to figure out how well we're doing. And that's why it was very, very useful to have Zenaida and Aguirre-Munoz. And Maribel is going to talk to you about what kind of assessment they actually did. This is Maribel and this is Maribel.
Okay, so what was the assessments that we did? So at the end of every class, we did a post-assessment survey. And so I'm going to talk to you about the same way that Mayya did. So it's going to be what psychological factors did we see that improved? How did the students react to the classes? And why this is a promising method. So just really quick, the pre and post differences in the psychological factors that we saw were an increase in math interest, a decrease in math anxiety, an increase in STEM identity. But most important here is the increases and the decreases by marginalized groups, which is what the project was all about. So you see that math anxiety, for example, was really impactful and change for first-gen students. You see differences by URM in terms of math self-concept and STEM identity. And so then what did the students say about these interventions? So all students reported high satisfaction levels with the course elements that were introduced on average. So a high satisfaction levels with the mini lectures, high satisfaction levels with the projects, as well as the support systems and specifically with the learning assistants. And then why is this a promising practice? So we did an HLM, which is a multi-level model to see which were the predictors and looking with this as a dynamical system to see which of them were most predictive of a higher course grade. And so for classroom environment, it was active engagement. For student background, it was
first generation students outperforming non-first gen students. And then for math psychological factors, self-concept was more predictive of a higher course grade than, let's say, math anxiety, which is significant just in terms of being able to tailor the course to that specific URM or under marginalized or marginalized group to increase course success. And then finally, just a summary of all of that. So these are all the background factors that influence calculus grade. Math interest, self-concept was found to influence the course grade. URMs outperform non-URMs, and then first-gen students outperform non-first-gen students. And the psychological factors did not influence course grade above any other factors.
Okay, so that's sort of in a nutshell, what we did. And I want to leave it because of all the conversations that we've had over the last 2 days. It was a very interesting conference for me. You know, we've heard from a variety of different intersegmental talks and everything. But I wanted to kind of bring it back to the basics. And that is, if you look at what's needed in the workplace, and I've been kind of watching this over the last 20 years at least, and every time I see a survey of employers, time and time again, they're actually outlining the same characteristics that they want to see in the students coming out of higher ed, right? And time again, those characteristics are coming up, which is problem solving, communications, and analytics, analytical thinking, critical thinking. So every single survey of the employers, and we're talking about from Northrop Grumman to a construction company in town, everybody's telling the same thing. Kids need to solve problems. They need to be able to read. Now, what solves problems, right? What solves problems? And why math is relevant to that? It's my deep belief that one of the major goals of teaching mathematics is to teach reasoning. It's a very easy way to teach reasoning. Now, we need to ask ourselves, what do we teach in our classes? Do we teach reasoning? Or do we teach them to repeat a set of steps like monkeys and forget this sequence of steps 5 minutes after the test? And I really feel that the higher ed is really focused on the latter, and so is K through 12, unfortunately. Now, reasoning is also, as it turns out, is the only thing that the machines cannot yet take away from us, because, for example, there's a recent article by Apple engineers who just made all of the latest AI models, natural language models, take a simple test in terms of math problems. And almost all of them have experienced significant drop in their performance once you introduce, for example, some extraneous information. So the reasoning they showed was very, very flimsy. And the reasoning is what all of our colleagues outside of math telling us they want us to teach. So I really want all of us to kind of step back a little bit. I will use any AI technology which will help me teach that. But my goal should be to teach that. My goal should be to teach reasoning as a human, because that is the most valuable of the outcomes of the math classes. So I just think that we need to really think about it more in higher ed and K through 12. All right, thank you very much for your attention.
Presentation, please think of questions you have for both the first presentation or the second presentation, or questions that you might have for both presentations, since they're both about reimagining.
Yeah, I had a question for Michael first. Can you talk a little bit about the reorganization and different treatment of topics in calculus, which did your first semester? Yeah. Does that spill over into the second semester of the linear algebra course, or is that more traditional? Do you have a handle on how to teach that?
I have less of a handle on it, but it would be, you know, like it would really, that one would be more data science motivated. Like, so it would be a little bit more like the linear algebra you need for some of the data science stuff. But I think there would be, like, I think it would be conceptual in terms of the theory, you know, so like we'd be talking about like a basis and stuff, but linear algebra actually goes better because students just kind of need to know like what a vector is and how to add vectors, which isn't so algebraically tough. And multiplying matrices is usually like, it wouldn't be the focus, but that usually goes okay. So sometimes with like more, theoretical math, it's actually easier to enter into it because it's more, the ideas are more conceptual and you can use diagrams to show like, how do you go, like a matrix takes you from here to here. And if you do this like sort of inverse thing, you get to a different like basis and you can kind of just explain it with diagrams. So yeah, I mean, it wouldn't be like, you wouldn't need those algebra prereqs for that class. The thing I think right now, the reason we're thinking about it in a sequence is because we just need the students to start thinking a certain way in the first class and learn some of the coding. And that way they can like enter into the linear algebra class.
I do have a question for the other project that I would wait for somebody else to go ahead. With the learning assistants, we have a long tradition of learning assistants at my university. But one of the major challenges that we've had is institutional funding.
Yeah.
They talk a lot about how to do our work better.
They do, right.
How we're not, but then, they never want to invest in these things. So, was that supported by the grant? Do you have a plan for how to continue the program?
You basically hit it on the nail. And this is my current argument to our administration. So this research that we did shows that it's very likely, I mean, it doesn't show directly, this is only a 3-year project, we can track it, right? It's likely that some of the students, and I think in Fresno State, they have some numbers. So I think it's like something like their pass rate, because engineering faculty, Lalita, so she's in the School of Engineering, they have a huge problem because calculus serves as a barrier. So the students drop out of engineering, they drop out sometimes of college. The same thing happens at UC Merced because of calculus. So my argument to administration is very simple financial argument, is if you retain, based on calculations, if we retain 2 students only in the university, the income that the students bring in the next 3 years covers the cost of all the learning assistants for these classes. So if you are an administrator who cares, you would understand this financial argument, because it's a financial argument, because our university retention rate is an issue.
Yeah.
So this is my current strategy. Whether I'm going to find this reasonable administrator, I've been telling all the administrators that. And the good news is that our dean is very supportive. So he understands that. And so he's now providing 50% of the funding. Now the department now has, because the math department teaches more credit hours than anybody else. So we are getting more money. So we're covering a portion of that as well. What's going to happen with the portion that comes from the grant, I can't tell you yet. My hope is that I'm also going to get to our new dean of undergraduate education, who's going to pitch in as well. So the good news is now it's not just me, it's our dean also is fighting for that. There are others on campus because the learning assistants have been used. I mean, we kind of started this program because we brought in the grant, but physics has learning assistants now, chemistry. So my hope is that as an institution, we will realize that this is an investment, and this is actually a smart financial investment because it brings more money and the retention goes up.
It is very interesting when you start actually trying to find money. We do similar arguments.
As we see even here in this conference, I think a lot of times there is a disconnect between the world that administrators are living in and the world that we're living.
Yep. Yeah, well, there's a disconnect for sure. The other challenge that we have, and I wondered if you had insights into it, is staffing.
The learning assistants?
Yes, finding them because it's a time-specific work assignment. A lot of our students work jobs off campus that potentially pay better, and so we're competing with the tutor center, the STEM Success Center, who has a more flexible ability to move their hours around. If you're a learning assistant for a class, we need you at the time when we need you. And so, have you had any, experience or?
Well, we have a bit of a different experience because after the negotiations, after the strike at
Yeah.
Merced, our undergraduates are getting almost $28 an hour for this job.
I see, so just pay more. I mean, interesting, no problem.
Yeah, well, I mean, that doesn't mean that the recruitment is not an issue.
Yeah.
The recruitment is challenging, but we've now developed kind of a network to where to send emails, who to send emails to. A lot of them come back. What I am hoping to do, because one of the hats I'm wearing on campus is I'm a faculty director of the CalTeach program. I'm hoping to actually develop a class for math educators that they can take and get credit for by being the learning assistant.
I was gonna ask that question also, if you have a training or a.
They do take a class right now, but right now this class is not part of the math educators curriculum. But we are now introducing an education track into our math major. So that could potentially at some point come in as a class like that.
Mary, do you have a question?
Yeah, we don't have any of that problems at community colleges because we don't have learning systems. So we were on the instructors part, but we have smaller class size. I was interested in knowing about, on average, how long the mini lessons were. Because my faculty always ask how long.
We try to keep it on our calendar,
15 minutes.
15 minutes at most.
Okay.
So that's, 10, 15 minutes, and they can vary, right? Because there could be a subject where you talk for 5 minutes, but we're really trying to keep it no longer than 15.
I just suggest, if, classwork activities with learning assistants aren't practical in a certain situation, you can also do Kahoot quizzes interspersed throughout the lecture. Just keep student engagement, and it gives great feedback for the professor to see like how much students are.
Well, I can put them and manage the groups. So.
Yeah, I mean, the thing is like, there's Kahoot, there's clickers, you can do all the multiple choice you can. The problem is that if you really want them to dig deeper into the problem and figure out the reasoning part, it's very hard to do through Kahoot or through clickers or through anything, because you can just do multiple choice kind of a thing, quick multiple choice thing, right? And the whole point of the active learning is that significant portion of the class, they are actually spending figuring out, learning by themselves, learning from each other, learning from the learning assistants, and really exploring a more complicated problem than just, figure this out.
So I was told when I came to this conference, my faculty gave me a list of questions. So textbook, it sounds like it's the OER.
Yes.
Okay. The other question is, what types of questions do you have on your exams? The traditional question of evaluating that integral you had. I did in class the other day, but they want to know, because in a community college, they might not go to you. They might go to a more traditional four-year institution that just could, not as innovative as you. So we have to make sure our students have a lot of different
access to this thing. So we do a variety of different. So there's projects where they have more sophisticated problem, like figuring out how a water reservoir works with all the rates and everything. And then we also have more traditional type of problems, but a lot of them are also put in the context, right? With the application in mind, even if this application is, analyze this function and not just, compute this integral. So we have, OER materials that we're putting online have all of that. They have all the problems, they have all so we, once the Learning Lab releases them, then you have access to all of them.
I noticed they were on the PowerPoint that you had uploaded a few days ago. They're not clickable yet. So once it gets,
that is not to me, I'll show you the person who's doing that.
Okay.
And we have cohort coordinator. Oh, that's right, Ellen, hello.
Hi.
So Ellen is part of the group, which is cohort coordinators for our projects, and they're the ones who are developing. So you can ask Ellen, and Ellen will show you. Well, Ellen will immediately give it up to Frank. So we have, we've developed everything in the house, but the thing is that a lot of those materials, I actually not OER. So we have to go through and do a lot of digging to make sure that only the OER portion is released, and we're not releasing some of the things that we cannot.
I understand. We have a project too. Be careful.
Dwight, do you have a question for one about this?
Yeah, it kind of goes on to what Mary was talking about, but it is for both groups. Are your classes being taught by full-time tenure track, full-time teaching professors, part-timers? How are these innovative courses being staffed?
Well, our data science major launches next fall. So right now it's me. And then another math professor who's doing like more of the linear algebra class. But my idea for this, like this part, the way this class interfaces with our grant is that we're developing the materials at East Bay and then we're going to share them with community colleges. So my thought is anyone could teach it, but I think there will be an element of like, professional development to teach the class. Yeah.
And for us, it's all of the above almost, except for we don't really have any part-time lecturers because if we get a lecturer, they're what else are they going to do? So we have tenured faculty, we have pre-tenured, the tenured track faculty, we have full-time lecturers, and I think the same thing is for Fresno. So we have basically, because we have everybody who's teaching calculus is doing it, and we have a combination of people, different ranks.
Because we do have the situation where somebody will teach calculus at our place and at 2 other Cal States and at 2 CCs.
Yeah.
They've got 5 different syllabi for the same exact course.
Yeah, that's for us, that's less of an issue because all of our lecturers are pretty much full-time. So, yeah, but it is a concern. I mean, I've talked to community colleges, they have the same, you're in CSU.
Yeah, we're in CSU, but a lot of our part-timers are also at 2 or 3 CCs.
Yeah.
So this is also for both groups, but so you also mentioned that it's very hard to do applications and traditional calculus. What do you do with the theoretical foundational aspects of calculus, such as the theorems and the theoretical aspects of
Like,
mathematics?
can you give like a specific example?
Epsilon delta, mean value theorem, Rolle's theorem, just to name a few.
Would it be math?
Because those are probably not very applicable to biology students.
Yeah, so I mean that's sort of the idea, right? Is like this is an entry point into mathematics, so they don't need to like be doing that. And that the idea is that it's like people are scared of that. That's the truth. So I don't know that, in my opinion, it's not the best idea for that to be as a community, to be our first foot forward for these students. So this is a way more like engaging and application based. And like, I don't know that, like those students, like remember those theorems and use them in their field if they don't stay in math. But these classes, I think both are going to teach them what those theorems do, which is the critical thinking, right? So they're getting the skills that they come out with a traditional class with anyway, but hopefully they're actually getting it more. That's my answer. And then, like, I think if this sequence was what the STEM pathway was, that more people would maybe want to go into math. And then you could start, like, instead of them doing the calc sequence, they take analysis as like a sophomore in college. And that's when they really learn their theory, right? That's my dream.
We have a bit of a different situation because Michael is teaching it to biologists, right? We're teaching it to everybody. And but we went through curriculum with a toothpick and we very carefully chose the theorems, which again, we can approach constructively from the tools perspective. For example, some of the theorems are telling you about how different sequences with different rates of change, right, are related to each other, right? If you bound 1 by 2, which are converging to the same thing, this is going to be converging to the same limit. So, but again, I think that even those which we usually perceive as a more theoretical tool can be taught very differently than here's the theorem, here's the proof, right? Because, for example, I'm teaching a lot of upper division classes and graduate courses. And even in those courses, I never teach it like that because I'm an applied mathematician. So by the time we state the theorem, I already explained to them through the proof of why we actually got it in that way. Why was it needed? So that then the theorem kind of falls out of like, look, we needed to bound this arrow and we bounded this arrow and voila, we get the result. So
Thank you, everyone. If you could, before you leave, open up your Whova app and go to surveys or go to the agenda and pick the session and then pick session feedback. You will give us some valuable data and research, and you will also be entered for a raffle.
Is this the raffle with the free stay?
No, that's for bingo. If you want to do that, get your.
Yeah, I've
get your
already,
bingo
I've
back.
already lost that. Yeah.
I wonder how many people, but the thing is with that thing, people can just mark and return. I mean, this.
Yeah, but we have a bunch of nerdy, like good.
I know.
Wholesome people, Maya, none of
Yeah,
us.
honor, schnoner, you know, but.
I mean, like, what's
You
in
hold
the
yourself to the
prize?
same standards you hold your.
Yeah, and a lot of them are cheating.
Oh, well, then I would.
Then you cheat for 2 nights at Luskin, okay.
All right.
Nice job, nice job.